Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Determine the molecular formula of 3-ethyl-2-methylpentane. 3-ethyl-2-methylpentane, pentane backbone, 5C, plus ethyl group at C3 to C, plus methyl group at C2, 1C, is equal to 8 carbons total. Counting hydrogens, C8H18. This is an octane isomer. Step 2. Check option A. Option A shows a straight zigzag chain that, by counting the vertices and endpoints, gives 8 carbons, an octane, C8H18. This has the same molecular formula as 3-ethyl-2-methylpentane. It is an isomer. Step 3. Check option C. Option C shows a branched chain with a downward methyl group and adjacent substituents. Counting carbons, the main chain plus branches totals 8 carbons, C8H18. This is consistent with 2,3-dimethylhexane or a similar C8H18 isomer. It is an isomer. Step 4. Check option B. Option B shows a structure with 2 methyl branches on a shorter chain. Counting carefully, the structure drawn appears to be 2,4-dimethylpentane, a 5-carbon chain with methyl groups at C2 and C4 giving only 7 carbons total, C7H16. This has a different molecular formula from 3-ethyl-2-methylpentane, C8H18. Therefore, option B is not an isomer of 3-ethyl-2-methylpentane. Step 5. Conclusion. Because option B has a different molecular formula, C7H16 versus C8H18, it cannot be an isomer of 3-ethyl-2-methylpentane. Therefore, the correct answer is B. Therefore, the correct answer is option B.